There it is. So let's do some philosophy that matters. That's the point of the current book. This is not the book that you just heard about. That was the last book that I authored as a... Yeah, let's not go to sleep too early. Thank you. Let me put you to sleep in a few minutes. The book you just heard about is the one that I authored most recently. This one is a co-authored, co-editor thing. So this is a collection of essays, actually. And it is about science and pseudoscience, or what philosophers call the demarcation problem. And I'm going to tell you a little bit about it for a couple of reasons. First, because I think it is actually an important issue for the secular community. And second, because I think that a lot of people don't appreciate how philosophy is actually done, and so you'll get a little bit of a flavor about what a philosophical discussion looks like. Now, the first thing is, why do we have a problem exactly? What is the problem? And roughly speaking, the problem is, how do we make sense of the distinction between things that we consider pseudoscience, like astrology on the left, and things that we consider science, like astronomy on the right? Now, you can look at them and say, well, I can see the difference. But that doesn't really help very much. That's like saying that the difference between, art and pornography is that you can see it. Well, yeah, but I'd like to know, why is it exactly you think that something is art and something is not art? What kind of criteria, what kind of sort of concept, what is the concept we're trying to get at? Now, that may seem like, just the kind of things the philosophers indulge in, until you realize that there are actually at least 3 different reasons for being interested in the problem. One is inherently intellectual. I and several other people think that this is an interesting problem. It's an issue of what are the conceptual demarcation between different fields? What makes something a science? What makes something not a science? But other than the intellectual interest, if it were just a matter of intellectual interest, this would just be a matter for scientists and philosophers to talk about, and there would be no reason for the rest of us to get involved in. The reason this is important for the rest of us is twofold. First of all, science gets a lot of money every year from governments worldwide. The majority of scientific research is funded by governments, which means it's funded by us as taxpayers. So it makes perfect sense for the public to ask, well, what is it exactly we're funding? Is this worthwhile doing? The NIH, the National Institute of Health, for instance, over the last several years has been funding research on alternative medicine, so-called alternative medicine. And one can reasonably ask, well, do I want my taxpayers' dollars to go to something that really most people consider a pseudoscience, like homeopathy or acupuncture, things like that? The other reason to care is because pseudoscience hurts people and sometimes downright kills them. This woman that you're looking at there has a tattoo on her pregnant belly that says no AZT. AZT is the major drug, antiretroviral drug, which is used in the treatment of HIV/AIDS. The reason she has that tattoo is because she doesn't believe that HIV causes AIDS. In other words, she rejects the scientific explanation for the AIDS epidemic, and she subscribes instead to a number of sort of pseudoscientific alternatives. I should say she subscribed because she died of AIDS, and so did her child. So this is the kind of thing that actually matters. Okay, trying to figure out what is crap from what is good science actually does literally kill people. So let me tell you the story now from a sort of more philosophical perspective. There is a little bit of the story of the demarcation problem is long. I'll make it brief by doing 3 major stops basically along the way, just to give you a flavor of how the discussion has been going for a while. So this guy over here is Sir Karl Popper, a major philosopher of science from the early part of the 20th century. If you've ever heard of the issue of the concept of falsifiability in science, about which I'll talk about in a minute, you know who Popper is. Popper was very influential in his time. Popper was interested in the demarcation problem. In fact, he's the one that coined the term demarcation. And Popper said that, look, the answer to the demarcation problem is that pseudoscience is characterized by the fact that pseudoscientific theories are untestable. They are more specifically, they are unfalsifiable. There is no way, in principle, to reject them if they're wrong. And his examples, interestingly, of pseudoscience were Marxist theories of history and Freudian psychoanalysis, which is kind of interesting because most of us actually think of Marxist theories as historical, not scientific, and Freudian psychoanalysis as some sort of science. But it turns out that there is no way to falsify, for instance, Freudian psychoanalysis. Freud was very famous for always finding a way to somehow reconcile the facts with his theories. Even when he had, for instance, patients who were behaving in very different ways from what his theory allegedly predicted, his reaction was, well, this patient has a problem with me, she's reacting to me personally, so she's consciously or unconsciously trying to undermine my theory by behaving in a way that it's opposite to what my theory predicts. Okay, which of course confirms my theory. Now you realize that if you go about it that way, then there's no way the Freudian psychoanalysis could actually be falsified. And so according to Popper, that means that Freudian psychoanalysis may actually work as a practice, but it's not science, because it doesn't put forth scientifically testable, falsifiable hypothesis. As opposed to, let's say, the general theory of relativity, which around that time, in 1919, had been spectacularly confirmed because Einstein had made very specific predictions based on his theory about what astronomers should observe during an eclipse of the sun. Astronomers went out there, took the measurements, and sure enough, the predictions were in fact perfectly upheld. Now, for Popper, what it's important to understand here is that for Popper, that didn't mean that the general theory of relativity was true, because Popper thought that there's no way to tell whether a theory is true or not. It just meant that it wasn't false yet, at least. It had survived yet another round of tests. And for Popper, that was the difference between science and pseudoscience. That is, science puts forth ideas that can be tested, and then the test is done, and two things can happen. Either you survive the test, in which case you just basically survive another day to find another day, or you fail the test, in which case the theory is rejected. So he thought that he found the difference between science and pseudoscience. Pseudoscience makes unfalsifiable statements, science makes falsifiable statements. Turns out it's not quite that easy, unfortunately. So here, let me introduce two more characters, very influential early in this debate. One is Pierre Duhem, who was a physicist, who was interested in philosophical issues. And Duhem pointed out that actually things don't work in science the way Popper thought they worked. Whenever scientists find a theory that seems to be contradicted by the data, they can react in multiple ways. They can say, if they have reasons to believe that that theory is worth pursuing, they can say, well, let's take a look at what else might have been gone wrong. Maybe the measurements themselves were faulty, the data. Or maybe the way we analyzed the data was not that good. Or maybe there is something else about what we have assumed that has nothing to do with the theory that may come wrong. And this has happened, in fact, over and over in the history of science. Copernicus is famous for having gotten right the idea that the sun is the center of the solar system and not the Earth, right? But in fact, if you actually use the Copernican theory in its original version, you don't get good predictions of the positions of the planets in the sky. In other words, the theory gets the positions of the planets in the sky wrong. So according to Popper, it should have been rejected. It's like it doesn't work. It's been falsified. But astronomers, particularly Galileo, thought that, well, I think there is something around here. Let's work on it for some time. And that for some time meant actually about 50 years of working around. And then finally Kepler realized what the problem was. Copernicus had assumed that the orbits of the planets are circular, and instead they are elliptical. And if you make that change to the theory, then the theory works perfectly well and it makes predictions that are accurate and so on and so forth. But that's an example, as Duhem pointed out, of scientists facing a hypothesis that had allegedly been falsified and yet keeping working around it. So that can't be, so falsification can't be the answer to the demarcation problem. Things got even worse a little later, in the 1950s and 60s, when this guy, Quine, who is a major influential philosopher of the time, pointing out that in fact science itself is best thought of as a web of knowledge with a bunch of threads that are interconnected to each other. And a theory is a particular type, is a particular strand on that web. But it could be that if you find that there's something wrong with that theory, it could be that actually what really is wrong is somewhere down the line in the rest of the web. And the rest of the web includes everything that we know about the world, including our very tools of how we do science, including logic itself. So it could be that our logic is wrong, for instance, in some cases. So Quine basically said, no way. There is no way that we can actually falsify theories that clearly and that precisely the way in which Popper wanted. Okay. That put an end to the debate for a few years, because now people didn't know where to go from there. Popper had proposed a solution to the demarcation problem, to how to tell science from pseudoscience. Quine and Duhem said, no, that's not going to work. For a while, people thought about it until this guy came along in 1987, Larry Loudon, another influential philosopher of science. He's still active at the University of Pittsburgh. And he said, no, actually, it turns out that we should start even stop thinking about this sort of thing. It's the kind of problem that cannot be solved. And it cannot be solved because, Loudon said, of three meta-philosophical issues. Now, I get nervous when people talk about meta-philosophy, because I don't know what that is. To me, these are three philosophical issues. But regardless of what you call them, let me go each one for a few minutes about each one of them, because they are the kinds of problems that are still being discussed today, and that's what the new book is about. It addresses these kind of problems and how to solve them. So Loudon said, okay, the first problem is that we want to know about demarcation is, if we did have a demarcation problem, how would we know that we got it right? Anytime you want to use a solution to a problem, you have to know that somehow you got it right. Otherwise, you don't have a solution. You just make up stuff, right? So it's a good question. It's a reasonable question. The second question is, what set of necessary and sufficient conditions do we use to arrive at that answer? Keep in mind those words, necessary and sufficient, because I'll tell you in a minute what that means in this context. But think of it in this way. If I ask you to define water, you could give me a list of characteristics. You could say it's liquid at a certain temperature, it has a certain density at a certain temperature, blah, 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 blah. Or you could say it's H2O. H2O, having the molecular formula H2O is both necessary and sufficient for something to be water. It's necessary, meaning that if a substance is not made of H2O, it's not water. And it is sufficient, meaning that if a substance is made of H2O, that's it. That's all you need to know in terms to declare water. So Loudon wants that kind of solution to the demarcation problem. He says, I want a set of necessary and sufficient conditions that tell me what is science and what is pseudoscience, just like water. And as I'll tell you in a minute, that's not going to work. Third, what judgments are implied by labeling something scientific or unscientific? So in other words, why do we do this thing? What do we do it for? What is the point of doing this, going through this exercise? These are good questions. I don't think they're meta-philosophical. I think they're just philosophical, but whatever. They are good questions. So let's answer them one at a time. First question, how do we know we got it right? Now, according to Loudon, he says, well, the way to know that the philosophers got the demarcation right between science and pseudoscience is if we come up with a result with which the scientists themselves would exactly agree. And I say baloney. You don't do philosophy so that just you roll over and let the scientists take all the credit. That's not the way it works. What happens instead is that we should come up with a classification of science, pseudoscience, and other stuff that, broadly speaking, reflects what scientists think, but not necessarily in the details. So if it turns out that as a philosopher I'm given an answer to the demarcation problem that classifies fundamental physics as a pseudoscience and astrology as a science, I got a problem. That can't be. But if I give an answer that gets most of it right, like this one, that diagram, you can't see the details, but that diagram basically clusters different kinds of activities. On the upper side of the diagram you have physics, chemistry, biology, that sort of stuff. Those are really good sciences. There's no question and no debate about it. At the bottom of it, you have astrology, parapsychology, UFOs, creationism, all that stuff. Those are all pseudosciences. There really is very little debate about that. In the middle, you have, however, controversial disciplines. You have things like evolutionary psychology, for instance. The idea that modern human behavior can be explained by looking at the evolution of what our ancestors were doing during the Pleistocene. Well, that's a borderline case, because, yeah, the basic idea works, it's fine, it's sound, but how do you know what our ancestors were actually doing during the Pleistocene? There are no fossils of human behavior from the Pleistocene, so you don't have data. If you don't have data, are you really doing science? So there's a bunch of fields that fall in between where the the scientist may disagree with the philosopher. And that disagreement is interesting. I'm not suggesting that the philosopher automatically wins. I'm saying that those are cases where the debate becomes interesting, because those are the cases where we could have a discussion about, well, why do you think that this is a worthwhile thing to do, and why do you think it's not a worthwhile thing to do? So that's the answer to the first question. I think that, yes, broadly speaking, the philosophers better arrive to answers that more or less agree with scientists, but not necessarily in all the details. The second question was, what about the necessary and sufficient conditions? This is a quote from Lawden. He says, ideally, a demarcation criterion will specify a set of individually necessary and jointly sufficient conditions for deciding whether an activity or set of statements is scientific or unscientific, blah, blah, blah. This is philosophy talk for basically, I want water. I want something like water. But that's strange, because philosophers themselves have realized a long time ago, at least in the beginning of the 20th century, mostly thanks to this guy, Ludwig Wittgenstein, that a lot of interesting concepts simply do not admit of necessary and sufficient conditions for their definition. A lot of concepts are more complicated. They're inherently fuzzy. They're fuzzy, they have fuzzy boundaries, and those fuzzy boundaries are not because we don't understand the concepts, they're just is the way the concept is. Let me give you an example. So if I ask you to give me a definition of game, what constitutes a game? What kind of activity, well, how do you tell whether an activity is a game or not? Well, very likely, first of all, you're not going to be able to do anything like, oh, it's H2O, right? You're not going to have a very simple set of criteria and say, oh, yeah, this is definitely a game, this is definitely not a game. What you're going to do probably is to tell me a series of properties that games share. Like they have rules, they're played for fun, there's a winner and a loser, that sort of stuff, right? But the problem is that for any criterion, you can try this exercise at home if you like, but from every criterion you give me, I can always come up with an activity that shares that criterion and is not a game. Or I can come up with an example of a game that does not actually share that criterion. So for instance, if you tell me, well, there's always a winner and a loser, well, so there are winners and losers in war, but war is not a game. And besides, there's solitaire, where there are no winners and losers. Okay? And you can do that over and over with all these criteria. It's kind of a fun game, actually, in itself, to do. And it turns out you just can't do it. So Wittgenstein said, well, does that mean we don't understand what a game is? Of course we understand it. But the way we understand it is we go around and say, and explain to other people who may ask about games, is, well, that's a game, that's a game, that's a game, that's not a game. And that one is kind of in between. I don't know what to tell you. It's got some of the characteristics of a game, but not all of them. Okay? And the same, I think, works for science and pseudoscience. As I said already, in certain cases, that diagram, by the way, shows a number of disciplines, and they are organized by the strength of their theoretical sophistication, and, how strong the theory is, and the strength of their empirical data on the vertical axis. So you got, for instance, again, the easy cases, creationism is on the lower lower left corner, because there is no theory there. It just says God did it. That's not a theory. And there's no data in favor of that theory. At the opposite extreme, you have, particle physics, for instance, where there is a very sophisticated theory, in fact, the most sophisticated mathematical theory we have about how the universe works, and also a lot of data. Okay, quantum mechanics, general relativity, they're confirmed by a huge amount of data accumulated over the last century. But then you got things like the social sciences, for instance, psychology or economics. They're on the upper left side of the diagram. Those are things where you have a lot of data, but the theory is kind of shaky. In fact, psychologists don't really have an overarching theory of how the human mind works. They have a lot of data, and the data are interesting, and they're reliable, they're repeatable. You can do experiments in psychology, repeat them over and over, you get the same results. But you don't have an organic overall theory of how they work. The last time that psychologists did have a theory was Freudian psychoanalysis, and we already found out what happened to that one. Okay. And then there's things in between, other things in between, like search for extraterrestrial intelligence, for instance. Very little theory. The theory basically says, oh, we hope there's somebody out there like us, and no data. Okay, not a single case. Now that could change tomorrow, of course, in which case that science would jump straight up there, because all of a sudden the data would be relevant. But right now there is no data. And then you notice over there on the lower right corner, there is something called string theory, which is the most interesting and controversial theory in fundamental physics. It's mathematically incredibly complicated. It's more complicated than quantum mechanics, if possible. There is precisely no data about that theory. There is no empirical confirmation of the theory yet. So at the moment, it stays there. If it should ever be confirmed, then it would jump up there. So I'm giving you a dynamic view of science and pseudoscience, right? I'm telling you basically that the extremes are easy to tell apart, just like, we all know that tennis is a game, and we all know that war is not a game. And then there are some interesting parts in between that are more difficult to tell apart. It's just like, sex. Is it a game or is it not? Well, it could be a game. But, you don't necessarily do it for that reason. Okay. Now, so what I'm suggesting here is that we move from, the answer to the demarcation problem depends on moving from standard logic, the kind of necessary and sufficient condition kind of logic that classical philosophy deals with, to something called fuzzy logic. And fuzzy logic is actually a technical term. This is the logic on which your computers, by the way, these days run. So it works. We know that it works. Well, except for Windows. But anyway, it works, usually. Now, people might be bothered by this because they say, well, but the nice thing about classical logic is that it's precise. If you ask me what is the definition of water, I tell you H2O, something that has an H2O formula. That's very precise, that's very specific, right? If you go to fuzzy logic, you lose in precision. Because all of a sudden you say, well, it's something that in between blah, blah, blah. But I think you do gain in significance. Things become more significant. The answer that you give is more actually pertinent to reality. Now let me give you a picture that shows what the difference is between precision and significance. The guy on the left says, a 1,500 kilo mass is approaching your head at 45.3 meters per second. That's very precise. The guy on the right says, look out. That's not precise, but it's very significant because it takes much less time to give that kind of information, and you get the hell out of the thing that is falling out. And then later you might worry about whether it was a mass of what type and what speed. So going from standard logic to fuzzy logic, you may lose in precision, but you do gain in significance. Now, the last question that Loudon had was, what do we care? What do we do this for? What is the issue here? And this is part of a quotation from Loudon himself. He says, philosophers should not shirk from the formulation of a demarcation criterion merely because it has judgmental implications associated with it. So it's okay to pass judgment for philosophers, basically, that's what he's saying. But the value-loaded character of the term science means that the labeling of a certain activity as scientific or unscientific has social and political ramifications. So he says, it's okay to pass judgment, but on the other hand, be careful when you pass judgment because it has consequences. Which means that in my mind, Loudon wants to eat his cake and have it too, as that cartoon says over there. You see that on the left says, have cake, eat it too, and the guy on the left says, let's keep this quiet, shall we? The problem with this is that Loudon seems to waver and be afraid that all of a sudden philosophers are going to be accused of passing judgment about socially relevant issues. Now, philosophers have absolutely no trouble passing judgment about socially non-relevant issues. That's what philosophy is about. Philosophy is not a descriptive discipline. It's a prescriptive discipline, meaning that philosophers tell you what you ought to do, or the way things ought to be, not the way the things are. It is the science province to tell you the way things are. But whether you should do something or not should do something, that is a question for philosophers. So normally philosophers have absolutely no trouble telling you what to do or what not to do. But now all of a sudden Loudon says, well, you should really be careful about it because it has social consequences. And I'd say, good. So that makes philosophy relevant to the rest of society if it has social consequences. What kind of social consequences? Let me give you a very brief example. These are some disheartening statistics about how many Americans believe crap, which is the technical term in philosophy of science. So these are percentage of Americans that believe in ghosts, UFOs, telepathy, haunted houses, blah, blah, blah. It's really bizarre. Okay. Close to 90% of American population actually does not believe in the theory of evolution as a naturalistic explanation for the history of life. 90. Okay? 50% are creationists, so clearly they don't, straight creationists, so they clearly don't. But even the rest, most people tend to believe that evolution works only because it's guided by the hand of God. Now imagine if you were saying, yeah, I believe in gravity, but only because God directly makes things fall down, and companies end down with the. By the way, this was actually a theory of gravity before Newton, that the universe inside itself is actually held together actively by God, moment by moment, and if God gets distracted, the whole thing falls apart. Fortunately, he cannot be distracted. He's God. So that's the state of affairs. Now, let me give a very specific, just in closing, a very specific example, recent example of how philosophers basically ignored Laudon and got into the fray and got some interesting results, some good results that actually are affecting the education of our children. So back in 2005, there was a very important court case in Dover, Pennsylvania. It was the first case nationally about the teaching of intelligent design, which is a slightly more sophisticated version of creationism. There's been many cases about the teaching of creationism. They're always lost, by the way. Creationists only won one case in the entire history of the legal history in the United States. That was the Scopes trial in 1925, which was overturned later on a technicality. But after that, they lost every single court case. This was the first time, however, where instead of talking about creationists, they were talking about something that sounded a little more sophisticated, like intelligent design. Okay, so that's Judge Jones III, who is a conservative judge appointed by George W. Bush. And so the creationists thought, hey, we got a good shot here. Okay, the judge, to their astonished, surprised, completely dismissed their case and actually accused the people involved of essentially acting in bad faith throughout the trial. It's a really interesting trial. There's a documentary about it. But if you read the conclusion that Judge Jones arrived at, it's a 40-page conclusion. You can download it off the web. It's very interesting both on legal grounds. It tells you what the legal grounds are for not allowing the teaching of intelligent design in public schools. But it's also interesting from a philosophical ground, because in fact, two of the major witnesses at the trial were two philosophers of science, Barbara Forrest and Robert Pennock. And if you read the conclusion of the judge, it reads like a Philosophy of Science 101 textbook. It's just, and let me give you a flavor of it. This is directly from the decision. It says, intelligent design violates the centuries-old ground rules of science by invoking and permitting supernatural causation. That's an example of demarcation. It tells you that science has nothing to do with the supernatural, and therefore, if you bring in the supernatural into science, you're not doing science anymore. Expert testimony, and that expert testimony was by those two philosophers, reveals that since the scientific revolution of the 16th and 17th century, science has been limited to the search for natural causes to explain natural phenomena. This is a philosophical argument that the judge heard, understood, and essentially incorporated in his decision. So this is an example of something that started out as a purely intellectual philosophical problem in the early part of the 20th century. This was Popper asking himself, what is the difference between science and pseudoscience? And then throughout a century of debate, eventually ended up with philosophers actually testifying in a trial that has had major consequences. Not only the plaintiffs lost on the intelligent design case in Dover, but there has not been any significant challenge, legal challenge, based on the teaching of intelligent design since. Because that case, even though it's not a Supreme Court case, actually sets a precedent. And so in order to mount another legal challenge in favor of the teaching of intelligent design, you really have to show why Judge Jones got it wrong. Now, we're talking almost 8 or 9 years later, and still nobody on the intelligent design side has been able to overcome that kind of challenge. There hasn't been a single lawsuit since that has been actually gone forward, and we don't even expect that to happen anytime soon unless they come up with something completely different, which they will, because that's the history. When they lose, usually they regroup, and then 15, 20 years later they come up with something different. But so far they have been stopped in their tracks. That means that, at least in theory, children not only in Pennsylvania but throughout the nation can be taught evolution and cannot be taught intelligent design creationism. So that's all I wanted to say. If you want to know more, of course, there's the book, and you can get it. Easier to do it on Amazon, but it's up to you. Thanks very much for your attention.